Hi everyone, I am Narayana from Delhi Public School, Bhimavaram, HOD of Mathematics. As a part of online classes, today we are going to learn number systems of class 9th. Number systems is one of the important topic of class 9th and plays a very important role in our day-to-day life transactions. For example, if you want to count the number of objects such as number of students, population of a country. Apart from that, when you go to buy something in a market, it's very important topic. Let us learn more about number systems. Let's see here different types of number system. The first one is natural numbers. Natural numbers are nothing but counting numbers, which are 1, 2, 3, 4, 5, 6, 7 and so on. It means that there is no end for natural numbers. Here 1 is the smallest natural number and the largest natural number does not exist, which means in terms of mathematics it is infinity. Also, natural numbers are denoted by capital letter N. Next number system is whole numbers. Whole numbers are nothing but all natural numbers together with 0 forms the set of all whole numbers, which are 0, 1, 2, 3, 4, 5 and so on. Here 0 is the smallest whole number, whereas the greatest whole number does not exist, which means infinity. And whole numbers are denoted by the capital letter W. Next number set is, before that let us go through connection between whole numbers and natural numbers. You can see that 1, 2, 3, 4 and so on. These are also natural numbers. So I can conclude that every natural number is a whole number. But whereas every whole number is not a natural number, because 0 is a whole number which is not a natural number. Next number set is integers. Integers are all natural numbers, negatives of natural numbers and 0, which are 0. To the right side of 0 you can see 1, 2, 3, 4 and so on. To the left side of 0 you can see -1, -2, -3, -4, -5 and so on. Here you can see that the largest integer does not exist, which we will call it as plus infinity, and the smallest natural number does not exist, which we will call it as minus infinity. We can make some notes. Every natural number is a integer, but every integer is not a natural number. I can give many examples: 0, -1, -2, -3 and so on. These are not natural numbers. One more note: every whole number is an integer, whereas every integer is not a whole number. I can give many examples such as -2, -3, -1, -4 and so on. These are integers but not whole numbers. Next, we can classify integers into positive integers and negative integers. You can see 0, to the right side of 0 we can name them as positive integers, whereas to the left side of 0 we call them as negative integers. When it comes to 0, 0 is neither a positive integer nor a negative integer. Next number set is rational numbers. A number R is called a rational number if it can be written as P by Q, where P and Q are integers and Q is not equal to 0. Let us learn more about this through some examples. You can see here, one example is 2 by 3. It is in the form P by Q. And what are P and Q? P and Q are integers. Let's see. Here P is 2 and Q is 3, which are integers. Next, Q should not be equal to 0. Here Q is 3, which is not equal to 0. Therefore, it is a rational number. Let us see next example, -7. It is also a rational number because I can write -7 as -7 by 1. I can make denominator as 1, -7 by 1 without changing its value. Here P is -7 and Q is 1. Both are integers. Q, which is 1, not equal to 0. Similarly, 0 is also a rational number because I can write 0 as 0 by any non-zero integer. I can write 0 as 0 by 1, 0 by 2, 0 by -99 without changing its value. 9 is also a rational number. I can write it as 9 by 1. You can see next example, -5 by 7. P is -5 and Q is 7. Both are integers and Q, which is 7, not equal to 0. You can see next example also. I hope it's clear. Let's go to the definition once again. A number R is called a rational number if it can be written in the form P by Q, where P and Q are integers and Q is not equal to 0. Rational numbers are denoted by the capital letter Q because P by Q form, which is also called as ratio, or it is also called as a fraction form, and this is also called as quotient form. When you divide P by Q in the division process, the answer is called quotient. So that's why we are using the letter Q. Let's see some remarks. Every natural number is a rational number because I can write all the natural numbers in the P by Q form. Next, every whole number is a rational number. Every integer is a rational number. So natural numbers, whole numbers, integers, you can write them in P by Q form by assigning denominator as 1. Next, every fraction is a rational number. Next, the square root of every perfect square is a rational number. We will learn about these in detail in the coming classes. Right now, let us assume the square root of every perfect square is a rational number. I can give you some examples on this, such as, you know about square roots. Square root of 4, square root of 9, square root of 16 by 25. Yes, here 4, 9, 16 by 25 are perfect squares because I can write all these numbers as a product of two equal factors. I can write this 4 as 2 into 2, 9 as 3 into 3, 16 by 25 as 4 by 5 into 4 by 5. When you simplify, you will get root 4 as 2, root 9 as 3, root 16 by 25 as 4 by 5, which all are rational numbers. I can write this as 2 by 1, 3 as 3 by 1, already 4 by 5 is in P by Q form. Got it? Next, every terminating decimal is a rational number. I can give some examples, terminating decimals such as 1.25. Let us take one more example, 0.09. I can write 1.25 as 125 by 100 and 0.095 as 95 by 1000, which are in P by Q form. So we can say every terminating decimal is a rational number. Next, every non-terminating and repeating decimal is a rational number. I can give some examples which are, you can consider 2.3 bar. 2.3 bar means which is equal to 2.333 dot dot dot. This also you can convert into P by Q form. We will learn how to convert them in our coming classes. Just now assume that terminating decimals as well as non-terminating and repeating decimals are also rational numbers because we can write them in P by Q form. Yes, so let us recall what we have learned in rational numbers. Every natural number is a rational number, every whole number is a rational number, every integer is a rational number, every fraction is a rational number, every terminating decimal is a rational number, every non-terminating and repeating decimal is a rational number. The square root of perfect square is also a rational number. Next, let us go through some examples what we have learned. Let's see what we have learned so far. Let us apply those concepts in solving the problems. State whether the following statements are true or false, but you have to give reasons for your answers. If you say true, then you have to give the answer. If it is false, then you have to give the answer. Let us see the first statement. Every natural number is a whole number. This is true. Because 1, 2, 3, 4, 5 and so on, all these are natural numbers which are a part of whole number. So it's true. That's the justification. Next one, every integer is a whole number. This is also true because in integers you have 0 to the right side of 0 are positive integers, to the left side of 0 negative integers. So it's true. Yeah, let us look at the statement once again. What was the statement is, every integer is a whole number. The answer is false because in integers you have 0, -1, -2, -3 and so on. To the right side you have 1, 2, 3 and so on. Here you can see that -1, -2, -3 and so on, these are not integers. These are not whole numbers. They are integers but they are not whole numbers. I can show you through a number line. 0, 1, 2, 3 and so on, -1, -2, -3. Yes, you can see -2, -2, -3, -1 and so on are integers but they are not whole numbers. Therefore this statement is false. Let's see the next question. Every rational number is an integer. Yes, this is false because I can give many examples. Let us consider one example. 2/3 is a rational number which is not an integer. This is one example. You can give number of examples. Or you can go for -10/7, 9/2 and so on. Let's see one more example. The next question is 0 a rational number? Can you write in the form p/q, where p and q are integers and q is not equal to 0? The answer is 0. Is a rational number? Yes. I can write 0 as in p/q form as 0 by any non-zero integer. I can write 0 by 1, 0 by 99, 0 by -10 without changing its value. I wrote 0 as 0 by 1. So answer is yes. Can you write in p/q form? Yes, I wrote in p/q form 0 and 1, and the condition is, look, P and Q are integers. Here P is 0 and Q is 1. Both are integers, and one more condition is Q should not be equal to 0. So here Q is 1, which is not equal to 0. Therefore it is S. Next, let us learn some more about rational numbers. Now here we are going to learn insertion of rational numbers between two given rational numbers. If two rational numbers are given, you can insert any number of rational numbers using this formula. If A and B are two rational numbers, then half of A plus B is a rational number between A and B such that A is smaller than half of A plus B, which is smaller than B. Here I assume that where A is smaller than B, then we can say that A is smaller than half of A plus B, which is smaller than B. Once again I will read. If A and B are two rational numbers, then half of A plus B is a rational number between A and B such that A is smaller than half of A plus B, which is smaller than B. Now there you may have a question, how many rational numbers can we insert between two given rational numbers? In fact, we can insert unlimited number of rational numbers. There are countless rational numbers between two given rational numbers. Let us learn how to insert any number of rational numbers between two given rational numbers through our sums. Let's see one example based on insertion of rational numbers between two given rational numbers. The question is, find 6 rational numbers between 3 and 4. I can solve. In your textbook they have given 3 different methods. The one method is using the formula. That is one way. And the second way is you can write these two numbers in decimal form and you insert it. That is the second way. And the third way is make their denominators same and then insert. But what I feel is students are very comfortable with second method and third method, whereas the first method using the formula, children find it little bit difficulty. Those who are extremely good in maths, they can do the using the formula also, but I suggest, as most of the children feel challenging, so what I feel is they use either second method or third method. Let us see the third method. I will make the denominator same. Let us see here, the given two rational numbers are 3 and 4. First of all, 3 and 4 both are rational numbers because I can write them in P by Q form as 3 as 3 by 1 and 4 as 4 by 1. Fine, let's see. No. Compare the numerators. Here the numerators at 3 and 4. Between 3 and 4, is there any integer? No. On the number line, after 3, the next integer is 4. So I cannot insert. So what I will do is, I will make these denominators as equal by converting them into some other denominator. I can make both of them, for example, I can multiply numerator and denominator with same value without changing it. Let us think that it is 10. So 3 by 1 becomes 30 by 10 and 4 by 1 becomes 40 by 10. Now you can see 3 I wrote it as 3 by 1 and now I wrote it as 30 by 10. Now 4 I wrote it as 4 by 1, next I wrote it as 40 by 10. Yes, 30 by 10 when you simplify you will get 3. 40 by 10 when you simplify you will get 4. So these are called equivalent fractions or equivalent rational numbers, 3 by 1 and 30 by 10. Yes, now compare the numerators. Here the numerators are 30 and 40. You can see that 30 is smaller than 40. Now you can find out which integers are there between 30 and 40. Yes, between 30 and 40 we have 31, 32, 33, 34, 35, 36, 37, 38, 39. There are 9 integers. Yes, but we want 6. Out of this 9 you can choose any 6. Yes, and then you make denominator as 10 for them. Yes, now therefore I can go for 30 by 10, 32 by 10. As there are 9 integers I will choose randomly 6. Next one is 35 by 10, next is 36 by 10, next is 37 by 10, next is 39 by 10. Let's see how many we have inserted. 31 by 10, 32 by 10, 35 by 10, 36 by 10, 37 by 10 and 39 by 10. Let's count. 1, 2, 3, 4, 5, 6. Actually we have a chance of 9, but I have inserted 6 of my choice. Clear? Now 30 by 10 is nothing but, you can write this as, which is nothing but 3, and 40 by 10 which is nothing but 4. So I have inserted 6 rational numbers. This is one way. I have used method 3. There is no rule that you have to make denominator as 10. You can make it as any denominator, but the denominator of both the rational numbers should be same. Got it? This is one example. Now let's see one more example. Now here the given rational numbers are 3 by 5 and 4 by 5, which are already in P by Q form, and we have to insert 5 rational numbers. If you look at their denominators, 5, already they are same. If denominators are same, then you look at the numerators. Numerators are 3 and 4. Between 3 and 4 there is no integer. So what I will do is I will make denominators which are already same, but I will make them a bigger number. Yes, how to make? There are, you can choose randomly, but I will do one thing. How many I want to insert? 5. So you add 1 to 5, so 5 plus 1 is 6. This is one of the way. Yes, you can multiply, as both are same, you can multiply with 10, 100, 20. Yes, multiply and divide. But the one way is, so I want to insert 5, so 5 plus 1 is 6. What I will do is I will multiply and divide each rational number with 6. Let's see. So what I have done is, I have multiplied and divided 3 by 5 with 6. 3 6 are 18, 5 6 are 30. Next, I have multiplied 4 by 5 and divided with 6. 4 6 are 24 and 5 6 are 30. Now you can see the denominators are 30 and the numerators are 18 and 24. Between 18 and 24, I can insert integers which are 19, 20, 21, 22, 23. So exactly I got 5. Yes, so I can say, so 18 by 30 is smaller than 19 by 30, which is smaller than 20 by 30, which is smaller than 21 by 30, which is smaller than 22 by 30, which is smaller than 23 by 30, which is smaller than 24 by 30. You can see how many I have inserted. 1, 2, 3, 4, 5. So exactly I got 5. This is one way. Yes. So you, or else you can make denominators any bigger number which is equal. But this is one way. I want to insert 5. So 5 plus 1 is 6. So I have multiplied and divided each rational number with 6. So here 18 by 30, its equivalent fraction is 3 by 5. This is nothing but 3 by 5. And equivalent fraction or rational number of 24 by 30 is 4 by 5. So hence the required 5 rational numbers are 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. I hope you have understood how to insert any number of rational numbers between two given rational numbers using the method 3. Yes. Now this is the, I feel this is the best for students. They can use the formula, but which is a little bit of lengthy. That also we will see through one of the example. Let us see this same example. Instead of 5, let us insert find two rational numbers between 3 by 5 and 4 by 5 using the formula. Here A is equal to 3 by 5 and B is equal to 4 by 5. Therefore the rational number between A and B is, according to the formula, it is half of A plus B. Let me write the formula. This is the formula. A rational number between A and B is half of A plus B. Here A is 3 by 5 and B is 4 by 5. So is equal to half of 3 plus 5 plus 4 plus 5, which is equal to, as the denominators are same, so add the numerators, and the numerators are 3 and 4, therefore it gives sum as 7 by 5, which is equal to 7 by 10. Therefore I have inserted one rational number between 3 by 5 and 4 by 5, which is, I will write here, therefore 3 by 5 is smaller than 7 by 10 is smaller than 4 by 10. So I have inserted one rational number. Now let us see how to insert a rational number between 3 by 5 and 7 by 10, or 7 by 10 and 4 by 5. I have two options now. Either I can insert here or here. Let us insert here. Now a rational number between 3 by 5 and 7 by 10, which is equal to, here according to the formula, A is 3 by 5 and B is 7 by 10. Therefore, half of 3 by 5 plus 7 by 10, which is equal to half of, here the denominators are 5 and 10. Yes, so I can make this 5 as 10 by multiplying and dividing by 2. So here I can multiply with 2 and divide with 2. Then it will give you as 6 by 10. No, the denominators are same, so I can add the numerators, which are 7 and 6, which will add up to 13 by 10. Half into 13 by 10, which will give you product as 13 by 20. Therefore, our rational number between 3 by 5 and 7 by 10 is 13 by 20. Therefore, I can write it as, therefore 3 by 5 is smaller than 13 by 20 is smaller than 7 by 10 is smaller than 4 by 5. You can see here I have inserted two rational numbers, 13 by 20 and 7 by 10. The same problem, I have inserted 5 rational numbers using method 3. There the answer was different and here the answer was different. As I said, between two given rational numbers, we can insert unlimited number of rational numbers. So the answer may vary depending on the formula. Yes? Let us solve one more sum. Let's see here. The question is, find 10 rational numbers between 4 and 5. Here the given rational numbers are 4 and 5. Yes, I can write 4 as 4 by 1 and 5 as 5 by 1. Here I have to insert 10 rational numbers. So if I use method 1, it will take long time. So what I will do is, I am going to show you method 2, where I will convert the given rational numbers into decimal form. I can write 4 as 4.0, 5 as 5.0, or I can write it as 4.00 also. This I can write it as 4.00 and so on. Clear? Let us consider 4.0 and 5.0 now. .0 is smaller than 4.1, is smaller than 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, and this is your 5.0. Let us see how many I have inserted. 1, 2, 3, 4, 5, 6, 7, 8, 9. But I want 10. So what I will do is, anywhere, as you know, between two given rational numbers we can insert uncountable. So what I do is, here anywhere, let us think here, 4.3, I can write this 4.3 as 4.30, this as 4.40. Yes, so I can insert between these two one more, which is 4.31 something. Yes, so here I can insert one more, 4.31, 4.32, 4.33 and so on. So, or here also, anywhere you can insert. Yes, let us insert here. 4.81 is smaller than 4.9 is smaller than 5.0. Now what I will do is, I will convert them into P by Q form, which is 4 is smaller than 41 by 10, is smaller than 42 by 10, which is smaller than 43 by 10, is smaller than 44 by 10, is smaller than 45 by 10, 46 by 10. Now this is 4.81, there are two decimal places, therefore it becomes 481 by 100 is smaller than 49 by 10, which is smaller than 5. So I have inserted 10 rational numbers. You can see they are in P by Q form. Here the decimal places are 1, so when you convert into fraction form you will get 41 by 10. Whereas here two decimal places, so it becomes 481 by 100. This is using the second method. I hope you have understood today's class. Let us have a look at what we have learned through a diagrammatic representation. Here I am going to sum up whatever we have learned through this diagram, through this Venn diagram, diagrammatic representation of rational numbers. So here you can see I have considered here natural numbers are there, which is in orange color, and the natural numbers are 1, 2, 3, 4, 5 and so on. When you add 0 to this, you will get the next bigger set, which is the whole numbers. You can see this one. Next, when you add to these when you add negative integers like -2, -16 and so on, then you will get the integers. For these integers, if you add terminating decimals, non-terminating and repeating decimals, which is 4.6 bar, you can see your terminating decimal is 0.2, non-terminating repeating decimal which is 4.6 bar, and fractions which are 2, 3 by 9, -5, 3 by 4, and you can add here some perfect square roots such as √4, √9, etc. Then you will get the rational numbers. I hope you have understood what we have learned today. As you know, natural numbers are denoted by the capital letter N, whole numbers are denoted by the capital letter W, integers are denoted by the capital letter Z or I. Why it is Z, you just find out and let me know on the given number on the screen. Next, rational numbers are denoted by the capital letter Q, because this form, when you write in P by Q form, that we will call it as a ratio, and that form is also called as quotient form. That's why we are using for rational numbers Q. And in higher classes you are going to learn about, there are some more numbers on the number line which are not in P by Q form, that you will learn in higher classes. Now what I will do is, I am going to give you some assignment which I am going to write on the board, and you can just mail these answers to me. On the screen you can see a number and an email ID, you can mail there. I have given you 3 questions as an assignment. The first question is, every rational number is a whole number. Justify your answer as true or false. Yes. Second one, find 5 rational numbers between 1 and 2. So you can use any method, either of 3. One is using the formula. The second one is converting them into decimals, and the third one is making the denominators same, and then you can insert. And the third question is, every integer is a rational number. Justify your answer. So when you want to justify, say either true or false with proper reason, and the reason may be any example. One example is enough to justify your answer. Please solve this assignment and just mail to the ID which is on your screen. Yes, I hope you have understood. If you have any queries about today's concepts, please give a call on the number which is on your screen. And we are going to have some more sessions in the coming days. So please be regular to my classes. This is going to help you to score good marks in exams. Apart from that, to have a fair understanding of the topics. Thank you.